things to consider when choosing a telescope. Right? So, here we'll get the lights off here.
Hey, Ron.
So this, oh, thank you. Thanks, Sean. So this talk, I'm not going to get into more like the technical aspects of particular telescopes and that, but more like an overview of things to consider that can lead you to getting the telescope that's going to accomplish what it is that you would need, you know, or want to get out of this hobby. So the first thing as an overview is that there have been a lot of changes that have taken place over the years, certainly since this club was first founded. So initially, the way that people would do astronomy, amateur astronomy, was just through optical telescopes. And when this club was founded 50 years ago, you could see the Milky Way from Naperville. And you could do a lot of work, you know, without worry. But times have changed rather dramatically from those times, and you know that's something now important to consider. So on top of that, we've seen things happen recently where you've had like Orion telescopes go out of business, you have Meade telescopes out of business, so we've seen some changes there, and that's another aspect to consider. So one thing I learned in researching this a little bit is that there is actually a good analogy with optical telescopes to what happened with pianos at the end of the 19th century. And so if we understand kind of what was going on then, we can get a better handle on, you know, what's happening with us with at least optical astronomy today. So first, when we look back at that industry that made pianos, the piano used to be the source for people in Victorian homes to be able to have music and entertainment. Then, you know, that was the only way that you could have music in your house. But then there was this new invention that came along, which was the phonograph. And for the first time, we could have recorded music. And so then people had an alternative to the piano. And so as a consequence, there was both a decline in interest and a decline in market share of pianos. And so we had piano manufacturers going out of business. But of course, we still have pianos today, but it was a change, right, from how things were done before. So this image here is where they are recording a live concert, one of the first times they ever attempted this in the 1880s. Right? So, you know, things changed. Likewise, with our hobby now, amateur astronomy is actually gaining in popularity, which is a good thing. And then there are things that have influenced that, such as very popular high-profile NASA missions, and you have online communities and social media. So people's interest is still definitely there. Yet at the same time, like with the pianos of the turn of the century, 19th century, 20th, there is a decline in the manufacture of optical telescopes. So things that have contributed to this, of course, has been the alarming rise of light pollution that has really impacted our ability to see the night sky naturally like we used to. And a rise in new technology, some of that inevitable, some of that in response to these changes, where now you can have alternative ways of being able to interact with the sky. So you have things like apps for smartphones that deliver instant high-resolution images and data. And so this becomes very attractive for a new generation of casual astronomers and young learners. So there are different ways that you can do this than what we had before. And so the upshot of this, like the pianos of old, is that we find that the interest in and market share of optical telescopes is declining. And so in part that has been one factor, not the only, but a contributing factor in the phenomena we see, like Orion telescopes going out of business. So another thing then that we have to do is we have to consider, when we want to get a scope, we have to take into account these changes. And the last comment I want to make on this is this fact that some places are out of business now has led to, we're going to have a future fundamentals on if you own a telescope already from a company that went out of business and it needs to be repaired, then how can you do that? So it'll be kind of self-help for people that own something that needs to be repaired, but now the place you bought it from is no longer there. So this has become a big thing. Right, so now, before we even get into like what telescopes to choose, let's look at this environment that we're dealing with now. So here I have 3 drawings I made of the same object, the globular cluster M13. So instead of showing you like, well, here's that cluster with 3 different telescopes, instead I'm showing you this cluster as it looks through the same telescope, but under different skies. So the top one there is a drawing I made when I was at a dark site outside of Illinois. So unfortunately now we do have to go outside of Illinois if we're going to get the best skies. So when I was here, this was a state park in Iowa, in a rural part of Iowa called Lineville, right at the border with Missouri. So at that time, this is over 10 years ago, it was incredibly dark. And then the benefit was, under those skies, I could get the most that my telescope could do. And so this was the result. So I could, even with a small telescope, at just 4.5 inches in aperture, I could already resolve stars in M13. And not random stars, but particular stars that you would actually see if you were to image this thing. If we look at the north, there's a diamond pattern of 4 stars that makes it unique. And on the west side, that is to the right, there's an optical triple star that you can see. So this to me was really cool. I'm really resolving this cluster and resolving it well enough that I can distinguish it from any other globular cluster now going forward. There's no other globular cluster will have that particular pattern of stars in it when you resolve it. In addition to that, I could see a galaxy, NGC 6207, that's in the same field of view. So that was really cool. This is part of how I enjoy visual astronomy. It's not just the target object that can be captivating, but you can see other objects in the vicinity too. It makes it more interesting. A big part of this is all you're trying to build motivation and interest. So the more you can see in the object, the more you want to go back and see if you can capture more things. The more that you see other things around it, that builds interest too. Like, well, what about that galaxy? Maybe I'll check that out in more detail next time, and so on. So that is when you have ideal conditions. So now the bottom 2 drawings are made in Illinois. And they're made like recently, just a year ago, right? So what we see here now is like, uh-oh, this is not anywhere close to what I was seeing before. All we get now is just the core of M13, and it's not even resolved. All the stars are gone. Certainly the galaxy and other interesting things nearby are all gone. So we have, in here, I'm going to say good news and bad news. So first, the bad news. This drawing on the left, I made on May 27th last year. I made it from Manuka, right? That's our club's dark site. The drawing on the right, I made just a couple months later from my balcony where I live now in downtown Chicago. So I live on Randolph Street, a block from the Aon Center. I really like living there. I'm close to work, number one, that's important, and it's a fun area for other things outside of work. But it's terrible for my hobby. And I thought, here, I'll just try a lark to see if I can even see anything. It's almost a joke. Why am I trying? And then to my surprise, I could see M13 from my balcony from this horrible light-polluted location. So then what that did, though, the good news, was that it inspired me. I said, if I can see M13 from this terrible location, what else can I see? And it turns out quite a lot. It kick-started my hobby again in terms of actively observing. And now I'm back doing an observing program for the Astronomical League with carbon stars, because I realized I could get down to 10th magnitude from my balcony. And carbon stars, many of them will be much brighter than that. So now I'm getting back into that program, and I'm also able to see other objects, planetary nebula, and even some beautiful star clusters. So it's been like really rewarding and surprising for me. So it means in spite of bad changes in our sky, there's still a lot of things we can do after all visually. So one last thing to mention about the Manuka view. If you remember what was going on in May of last year, we had a lot of smoke from Canadian wildfires. So they had drifted over Illinois, and that impacted what we could do here. So this is not representative of what Manuka would be. So many times it's going to be better than this. It will unfortunately not be as good as what outside of Illinois is. But also it's a reminder that we're dealing more and more now with unfavorable conditions, and that's something you have to keep in mind as well. So if you get into, I want to change the telescope, so we have to think about where are we observing from, and would you need to be able to take it places away from light pollution, or would you be able to do things here in spite of the light pollution? So just things to think about. So now that's kind of the first question to ask. So what do you expect to view, right? So what got me started in the hobby years ago was the planets. And they are the brightest things you can see in the sky. It's not a question of how do I find them. I mean, they're the brightest thing. I just point my scope there and I'm done. So no worries about finding objects. And then they're very rewarding. You can see surface features that they rotate, so surface features rotate into view, so it's always changing. And once you recognize these features, you realize even that they change over time. So that was a great way for me to be my in on this hobby. And then of course, after time, I got into deep sky and other things as well. So a thing for people to consider is what would be your in? What would be the thing that you find exciting and interesting to try? It could be the planets, or it could be deep sky things, star clusters, galaxies, that sort of thing. So whatever it is, you want to find something that piques your interest to kind of get you going. But then depending on what it is you choose as an object, then some telescopes are better at that than other scopes. There are really two fundamental things that work both for visual and imaging, and that's going to be field of view. There'll be some objects that really benefit from wide fields of view, and another set of objects like planets that benefit from the exact opposite, from very narrow fields of view but high power to really pull out the details, right, so that you can examine them. So we have kind of conflicting needs depending on which object you choose to concentrate on. So here would be an example of what I'm talking about. Here is an observation I made of the Andromeda galaxy. This was only a couple years ago. So it's still encouraging that you can get really good work done on deep sky objects still, but it's getting harder and harder. Now I have to go further and further west to accomplish this. So what I have here is, this is the galaxy as I could see it out there. And it's enormous. It's over 1.5 degrees across as I could perceive it, and in reality it's even greater in extent than that. If you have a bigger scope, even more is visible. So I compare that to scale with a circle representing the full moon, so you get an idea of how large an area this object is compared to the full moon. And then we have a small dot there that would represent a planet. And wow, small a planet is going to be in comparison, right, to the moon and Andromeda. So we can see then that, well, if I want planets, then I need high power, and I really need high power. I really got to zoom in there. But if I'm doing deep sky, then I need the opposite. I need some scope that gives me a wide field of view to really bring all of this in. So different scopes will help you depending on what you want to focus on. Right? So the last thing I had down in the bottom was a view of Andromeda, like from out here. This was Lombard, but not far from Naperville, so kind of what we would see here. Dramatic difference. Now, all we see is the core of the galaxy and one of the bright satellite galaxies, M32. That's it. We've lost the other companion galaxy, M110. There is a beautiful star cloud that I could see within Andromeda out west. That's gone too, of course. So it means, yeah, you can still do deep sky here, but now it's a different story than what it would be if you go to a dark side. And then correspondingly, we can begin to think of, well, what telescope then would work for me depending on where I'm going to be observing.
So how far west do you go?
So now I have to go to the desert southwest to get the best skies. New Mexico, Arizona, and western California, like Joshua Tree National Park and just south of that. I have been to Kansas, Cross Timber State Park. It worked really well for me years ago, and now as I've gone back, it's getting harder for me to see as well as I used to there. So there's definitely just this progression of light pollution over the years that has made things harder to do. So one last thing I want to point out here is just take a look at how Andromeda looks here, because there's now a new technology that I'm going to talk about that is electronic, and it's not a traditional telescope at all. It's called a C-star. And it will give you, I can put that on the balcony of my high-rise and see Andromeda electronically like this. And I would see it like this on my cell phone, because my cell phone becomes the eyepiece. This is completely different. My cell phone or tablet will control the instrument, right? But for people who like imaging, this is what the C-star can do. People who are really into imaging are going to say, this isn't close to what we want. We can do so much better than this with imaging. So there are different technologies now with different consequences. Let's also remember how small the planet is. And then if we have like a C-star, it can show you Andromeda, but now it's going to struggle with the planet to try and show that to you. So we'll get to that in a bit, but just wanted to point that out. So here, the last thing on just field of view, this is the Veil Nebula. So we can see if you're going for deep sky objects, they can take up like a wide area of space. So if people like to do imaging, the very popular telescopes are telescopes that are really, wide field, and now we can see this as well. There is, here with my telescope, which is a wide field scope, if I just have the standard 1 1/4 inch diameter eyepiece, I get a 2.5 degree field of view almost. So it's pretty good, but yet still not good enough for the whole veil. So my scope, as many scopes will have, is they'll give you an option where you can put in a 2-inch eyepiece. So I do happen to own one 2-inch eyepiece and 2-inch diagonal, that I can substitute in. Then I get a 4-degree field of view, and now I can get the whole veil in there. Then the other scope that I wanted to show here would be a great high power scope. That would be something like a C11, so 11-inch Cassegrain. And there, the field of view at the low power eyepiece is significantly reduced. So you're just going to get partial views of deep sky with a scope like that. However, then a scope like that is going to be ideal for planets or planetary nebulae, resolving double stars and so forth, right? Because we're going for a different thing. And being a much larger telescope than mine, it's going to have greater light gathering ability, greater resolution. So you're going to be able to see things so much better for those objects, right, with that type of scope. So I think this kind of illustrates where we're going, wide field, narrow field, each having their own advantages and disadvantages. So here we'll just touch on telescope types quick. There are 3 fundamental types. There are other variations that people have made, but these are the 3 fundamental ones, especially you'll see in the market. The one on the left is a refractor. That's like what I own now. And it has just a lens in front to gather the light, and then it focuses it in the back. And then you can put on a diagonal, so with a little mirror so that it can bounce the light up to the side to make it easier to look at. So you're not straining your neck by looking out at the back. So this type of design gives you the best views, hands down, because you have no obstructions at all. It's just direct light path from, right to your eye. So great advantages for having the best views, period. Now, you can make them 2 ways. You can have a short tube refractor, so that gives you wide field views. And then they are compromised for high power. And then you can do a long tube refractor. That's great for high powered views, but then compromised for wide field. One other thing with refractors, though, it's very expensive and difficult to make these lenses. So they tend to be smaller in aperture. So when you have these other designs, they are much better to get you more aperture, right? So that's what their value is. So the most practical is the one on the right. That's a Newtonian reflector. So there you have a mirror now gathering the light instead of the lens. The mirror is at the back of the scope. So the light goes through the tube. It's the mirror is focused then in a narrow beam to a secondary mirror at the front, which then directs the light again to the side so you can view it easily. So this is your classic Newtonian design. So because it's so much easier to make the mirror, these are the most cost-effective telescopes, hands down. So you can get a much larger telescope as a Newtonian than you ever could as a refractor. So benefits of larger telescopes are going to be they gather more light and they have more resolution. There is no substitute for aperture. So if you want more light and better resolution, bigger aperture, it just works beautifully. So drawbacks to that design, though, is now you've got a central obstruction. So the view is not going to be as clean as it is with a refractor. So you're going to then try to compensate for that by making the aperture bigger, right? Gather more light to offset the fact that we're having some interference now with the central obstruction. The last design that's very popular is the one in the middle. It's a hybrid between the two. It's a Cassegrain. So with these, you have a lens in the front like the refractor, but not nearly as, as involved a lens. It just will direct the light to a mirror, and then the mirror will send the light to that central obstruction again. But that's another mirror that will then send the light through a hole in the center of the primary mirror, and then to the back of the scope, where again you can have a star diagonal for ease of view. So what this does, it's a high power scope. It's a long, effective focal length. That is, it acts as if it was a really long tube, allowing the light to come to a nice focus. So high-powered views, but it's now this high-power scope in a compacted design, so that's what made them so popular. So you could mount it easily and handle it a lot easier. So that would be your C11 and scopes of that nature. So they are great high power, but now their drawback is not so good with wide field. All right, so now I'm going to show just examples of telescopes in all three classes. And these are all scopes that I owned or used to own, so I'm familiar with them. So this first one would be a typical beginner telescope. So what I currently own still as a second scope is a Meade 70 millimeter refractor. So that is a focal ratio of f10. It is the light will come to a focus at a distance 10 times that of the lens size up front. But because this is a very small lens that's under 3 inches in aperture, the tube still isn't very long, so it's very manageable. And because it's still a small lens, then you still get relatively low power views, so it tends to be kind of decent wide field, even though it's a long focal length. So it has a lightweight mount. This is an azimuth mount, and the azimuth also has a tray where you can put your eyepieces on. So I like this so much, I got a second azimuth mount, a little beefier, for my primary scope. Because it's so lightweight, it travels beautifully. So when I go travel with my larger refractor, I use an azimuth mount much like this, because everything is like lightweight mount, lightweight scope. It's beautiful. So the way these would work on an azimuth mount is you're going to balance the scope. You've got weight at the end where the lens is and weight at the back where the finder scope and eyepieces are. You find the sweet spot, and it's balanced really nicely. You don't need any counterweights. And so this makes this kind of scope grab and go. And grab and go is really important because it's for motivation too. It's like a clear night. I want to look at something. I don't have a big production to go through, right? If I just have the bug to view, just grab it out of your closet, out the door, and we're observing. So it means that you have motivation to use it a lot, and that's really good. So with scopes this small, they actually can do a lot. And there are, again, you find online communities that love these scopes, the 70 millimeter, 60 millimeter scopes. They've listed over 200 objects you can see with them. Certainly views of the moon are spectacular. But what I find with these small ones, especially if you're a beginner, you can do a lot with them if you're an experienced observer. So with small telescopes, the secret is they can show you much that the larger telescopes do, but it's just not as bright. So if you become an experienced observer and gain skills, observing skills, then you can pick out all these things with small scopes like this. It becomes second nature. But if you're just starting out, then it doesn't work that way as well, right? You need to have something brighter so that you can kind of get used to this and used to seeing objects and develop your skills. So I actually would not quite recommend something this small if you're just a beginner. But it's really helpful, you know, once you become an experienced observer for the grab and go. The other thing about these types of scopes is when people now go to imaging, where I don't want to visually view, but I want to get all these great electronic images of things, of deep sky objects. They're ideal for that. And ideal if you then upgrade it, go from something like, you know, $150 or $200 or something like this, like a simple Meade scope was, to something like a TeleView scope, or there are other popular manufacturers too, where we have a lot heavier glass up in front, And so that means that we're getting superior quality optics now. But yet, because it's so small, you can still take it on an airplane, and people do. And you can use it then to do your deep sky imaging, serious deep sky imaging, because it's now those types of scopes with the superior glass and making it on a shorter focal length are giving you fabulous wide field views. Right? So this class of scope, when you're in imaging, ideal, but you'd have to upgrade more, maybe around $500 or more on the scope itself, maybe $1,000 with the scope and mount, you know, because now you're going to do some serious work with imaging. So here is a refractor, a small refractor that is ideal for doing planetary work. So these are the classic scopes from like turn of the century, and what they are. I had experience with a scope like this when I went to college at the University of Illinois in Champaign-Urbana, and they have a 12-inch refractor there, and it's built in the 1890s, and it's long, and was some of the finest views I've ever had of the planets was through that scope, because everything is working for you for high-powered views. So you've got a light that's brought to a wonderful focus because you have such a long path to travel, and you got incredible contrast. And when you look at certain things like star clusters, let's say, it's the effect is what people call diamonds on velvet, where it's such a wonderful contrast. It's just a dark, deep black sky with the stars like diamonds scattered on it. So just a phenomenal view. The drawback, of course, is you're not going anywhere with this scope, right? It's just a monster, right? So if you have like a house you live in, you have to practically build your own observatory for something like this. There are other drawbacks too. We can't make the lens too large, right? So you can actually get similar superior views in terms of resolving detail with reflectors that are much shorter tubes and much more manageable. So here is another refractor. This will be the last of the refractors I'm going to talk about, and this happens to be the scope I own. It's my primary scope. I've had it over 11 years now. This is an Orion 120 millimeter refractor. It's a short tube refractor. It's really meant for wide field views. So this one is like only a couple feet long because it's f5. It's really fast. And this is the original mount that it came with that I still have. You have counterweights on it. It's an equatorial mount, so it means that it has a clock drive so that you can track things in the sky. So it means I can set it on a planet, let's say, and put the clock drive on, and the planet's going to stay put in the center of the eyepiece. And then if I want to make a double star, let's say, and resolve it, I can get high power with it, in spite of the fact that it's a short tube, by using Barlow lenses and higher powered eyepieces. So then this works really, like it is workable for high power. So the lens in the front, this is only was $300 or so to buy the optical tube, $500 for the whole thing, 10 years ago. You can get them used in a similar price today. So you have one area of compromise, which is the glass isn't substantial at that price up in front. So you're not getting like superior quality images because you're not using enough glass for that. So now this becomes an interesting compromise where what I like about it is that it's light and doesn't have enough glass, because this is really my travel scope too. So when I get my light azimuth mount, switch that out instead of this, I take this whole thing and put it in a suitcase, mount, scope, everything. And the suitcase is well under the limit of what an airline would have for a standard suitcase to check the bag. And now I can, and I've routinely done this, just, check the bag and it flies on the airplane with you. So incredibly portable. And because, in part, the glass is not that heavy. So when I think of the airlines, it's like Newton's laws, right? Which is force equals mass times acceleration. So if you want to protect the telescope, the less force you have to deal with, the easier it is to protect it and keep it well. So I can't control the acceleration because that is going to be the baggage handler. So the baggage handler of the airplane, they're going to give acceleration. I can control the mass. So if the mass is low, in spite of the acceleration, the forces will be low, relatively low, and quite manageable. But if I had a premium telescope with very heavy glass up front, now I got a problem. I suppose in theory you could try and travel with it, but boy, you got a lot more forces involved. It's a lot harder to protect that. It will cost 15 times as much as this scope to get the premium scopes, right, with the great glass and all of that. So that's something to consider. Wow. So for the price of one of these scopes, I would have to spend 15 times as much, $5,000 and such, for a premium refractor of this size and focal length, right? So then I had to consider, well, what am I going to get for that extra money? So I was able to really put this to the test because I was involved with very advanced observing programs with the Astronomical League, the Herschel 400. So they recommend there that you have a telescope more than twice the aperture of what I'm using, not twice as much, more than twice as much, because some of the objects are really challenging. You'll have a galaxy at 13th magnitude, effectively, that you have to pull out, or the blinking galaxy that disappears if you look at it directly, super low surface brightness. So it's going to challenge people with 10-inch apertures. And here I'm trying to do this with 4.7. And now my optics aren't the premium optics to give you the most contrast you can have. But I can take it to the darkest sites. And so it becomes, I learned from experience, the dark sites really override everything else. And then moment of truth would come for me. I'm 2,000 miles from home, literally, in a state park maybe, just myself in the sky. And the serious challenge object. And now like, oh, this is either going to work or it's not, and it works, right? And so then that gives me like, wow, I made the right choice, right? So that means the $5,000 telescope will give me a crisper view, but it's not going to make it that I can see something with that I cannot see with this. So these are interesting things then to think about if you're choosing a telescope, right? So this gave me the ability to travel, and the other one does not. I would be more like I'd have to drive wherever I'm going. I couldn't fly there. Then we get into kind of laws of diminishing returns. So you will have the premium scope, and they will be magnificent. You're going to get back to, diamonds on velvet and super contrast, easier to see anything than what I could do here. But yet, boy, are you spending a lot of money, for that improvement. So, these are all personal choices we make. There isn't necessarily a right or wrong, right? Let's see, what else could they say about this one? So there is a downside to this too. It cannot do it all. So one of the things I started with and I loved was planetary viewing, right? And so at the end of the day, this scope just isn't going to do, really well on planets because it's just too short a focal ratio, and you don't have the premium glass, right? So you just don't get the contrast with planets. So it works, it's workable. So now that I've, gotten to observe the planets a lot, my needs have changed, where I just want to kind of monitor things like what's happening with the red spot or something on Jupiter. But if I really wanted to dive deep into planetary work, then this doesn't work. So no scope can like do it all, right? You have to make your choices. What are the things that I'm really concentrating on now that I want to see, right? And so this is very serviceable, but still can't do it all. So here is a scope that's a very popular type of scope. It's an 8-inch Cassegrain. So in the 1980s, I had an 8-inch Cassegrain, much like this. And I was doing lots of planetary work, of course, with that at the time, and I loved it. So you have great high-powered views. It's really very stable with this short, compact tube, so it tracks beautifully. And so that did a great job for me, when I was really into my high-powered stuff. And it will do really good work on certain deep sky things, like imagine a double star you want to resolve, or a planetary nebula that is also very small, right? You want to magnify it and bring out the details. Even certain clusters and so forth, right? So, very nice scope. Now, this more modern version here has a hand controller that we see, and you can now get go-to in terms of how you find things. So I've always done, and still do to this day, I find every object through star hopping. I even star hop from my balcony when you can barely see a star. But once you get really good at this, once you really get experience, then it's second nature. So for beginners especially, though, it's going to be tough to star hop. So you really appreciate having a go-to where the telescope can find the objects for you. So the way this would work is if you go out in the field, you would point the scope at a bright star. You won't even have to know what that star is, but you point it at the star, center it, and then get the computer to register it, and then you repeat that with 2 other stars. So you've got 3 stars that you pointed it at. Now the scope can figure out, where everything is, and now it'll do the go-to for you. So they do have smaller versions of this type of scope, a 4-inch Cassegrain, which would be a good alternative to like my scope that I had. So similar aperture, not quite as good because the central obstruction will hurt, but still really good. And then you can it'll be very portable, certainly much more portable than this, and it will have the same kind of hand controller. So what would be the drawbacks on this would be if something goes wrong with the hand controller, you're done. Like you can't move the scope. So you have to be sure the batteries are fresh in there and that the hand controller is working. So with my scope, it's so simple. The simpler things are, the less likely it is that something goes wrong. So I don't have any of those issues. So I'd say for some people, go-to would be a wonderful thing, right? It just saves you a lot of time, especially when you're a novice at this, and you spend more time than looking at the objects than trying to find them, right? But once you get experience star hopping, then there are other advantages that you can have, like you can find the objects just as quick without having to futz with going from star to star. So here is the last design, the Newtonian telescope. So also back in the 80s, in the late 80s, I built myself my own Newtonian telescope. And I'm not very mechanical, so I was very proud that it worked, right? So with these, I like this particular model to show. What I did when I built my own custom is you don't need a tube, really. Like we see here, there's just these frames that we have for part of it. And that's all you need are frames to hold things in place. So you have something on top, which is like a light shield around the eyepiece. And then mine that I built myself, I had a similar, smaller, just light shield around the main mirror. And then it had more of just the frame. And it just works perfectly well. So again, the theory here is the light comes through hits the mirror in the back, it's brought to a focus at the secondary mirror up front and then sent up through the eyepiece on the side. Right? So these scopes are the most bang for the buck, if you will. So if you want larger aperture, this is the way to go. So you can spend, like at $500, I can get like a 6 or 8 inch dot very easily. So much more aperture than my refractor for the same money. And so then you get the benefits of greater light gathering power, right? So a lot of people would recommend a Dob to start with, because then, especially if you're a beginner, you want like brighter images to see things better. This certainly helps a lot. And as we see here, they've now made this is a particular type of mount, not an equatorial, but a Dobsonian. So it swivels at the base, so you can go right to left, and then swivels where the controller is up and down, right? So you can have one without a controller, where it's just, you just swivel and move it, or you can have ones now where they put in controllers and go-tos, and so this can be a go-to scope as well. And so that can be good then for people starting out. I got my go-to to find the objects for me, and I've got lots of nice aperture to work with, bright images, but it's not as expensive. There'll be a couple drawbacks with these, as I found. One of them is collimation. So these are opened on scopes. So the ones we've seen before, whether it's a refractor or the catadioptric hybrid, they're kind of all aligned in the factory, and then you're good, right? But these, they'll get out of collimation easy. So that means you'll have to, from time to time, work to get the mirrors, the primary and secondary mirrors aligned so that you're getting a sharp image again. So there's more futzing that way. And they're also much more sensitive to temperatures. So usually you have to take them outside and let the mirror adjust to the ambient temperature before you can really get your good views going. And lastly, the mirror will lose its coatings over time because it's exposed to the elements, and then you have to recoat it or get a new one. So there are some practical drawbacks to those. So here with the old Orion company that isn't around anymore, but they put this out because they offered different types of Dobs. I like this because it gives you an idea of what you can do. So the Dob I built way back when was a 12-inch Dob. I did that so I could get nice planetary views, nice light gathering power. Oh, it worked really nicely. But I don't have it anymore because it's really bulky and hard to move and take places. And mine was even longer than their 12-inch here. I had a longer focal ratio, because then it helped me. The secondary mirror was farther from the primary mirror, so a little less obstruction per se. Really crisp, sharp planetary views, right? But just not very practical in other ways. So one other thing we want to talk about with larger aperture is that it's not all wonderful with larger aperture. Because what we see, even as we compare these, is what's the light cone. So with the 6-inch, it's a small 6-inch wide light cone. With the 12-inch, double that. So that means these are sensitive to the stability of the air above it. So if we have unstable air, not too great seeing conditions, that's amplified as you get your larger scopes, so that you'll have a crisper view at the same night, at the same time, with the smaller aperture than the bigger one, because the bigger one is amplifying the bad, kind of instability of the air. So also, some people like to try these to compensate for light pollution, because you're gathering more light, so you can make up for the fact that the light pollution is trying to kind of degrade these things, and it only partially works, because now as our skies are deteriorating, it's a problem with the star images. They're getting bloated. They're not being sharp pinpoints. So if you have good conditions where the air is steady and the stars are tack sharp, you can see really faint stars. Because like with my small 4-inch scope, I can see stars to 13th magnitude very easily from a dark sight. Because they're all these beautiful point sources, and you can see really faint point sources very easily. But now, if this atmosphere is not stable and it begins to bloat the image of the star, then the star becomes an extended disk. You're spreading the light out over an area that makes it dimmer and harder to see. So that's why the same telescope can show only to 11th magnitude one night and 13th magnitude another. It's not the scope, it's the sky and what it's doing. And then for that reason, we can't just simply upgrade to a larger scope and completely battle deteriorating sky conditions. So you still have a good reason to try and go, away from bad skies to better skies. So now I'm going to finish with two scopes where we're doing imaging. So this one here is an Astrotech. It's a 72 millimeter, I believe, so that's just under 3 inches. And it's incredibly short, which is wonderful. So scopes of this nature you can take on an airplane with you. This one has heavy glass at the top, but because it's so small, it's still like you can take it with you. But what we like with this is wide field, right? Really beautiful wide fields of view. So you want to do things like we saw earlier, Andromeda galaxy, Veil nebula, things like that. This really can get them. Now what we're doing is putting a camera at the back, and then we're going to set this whole thing up, a nice equatorial mount to do our tracking. And now we are really good to go to do some serious deep sky imaging, right? So I don't do imaging myself, I never have, so I had to research this a bit. And then I got one thing from an imager who had posted kind of telling how this works, where he was saying with visual scopes, aperture is important. With imaging, it is the opposite. It's the F ratio, it is the wide field of view that is important. So when he does his imaging, he says like compare two scopes, and this is important because there is an imager I want to talk about who uses like the C11, C14 even scopes for imaging because he wants to do planets, right? So two different, totally different scopes for two totally different purposes of imaging, right? And then we remember now where I showed, okay, the Veil nebula and field of view wide and field of view narrow, right? So the guy doing the planet doesn't care about the wide field, he cares about zooming in, right? So with this scope, when you're imaging with a small scope, according to this guy, he is saying that the amount of light you're getting, it's brighter. I mean, this is true with lower magnification or brighter images. So he says he can get as much light in just 1 minute of exposure time as a C14 would get in 4 minutes. So remarkable, like this is not how visual works, right? So by the nature of how this works, you get more light in 1 minute exposure than you do in 4 minutes with the big scope, right? And he talks about his pixels and how they are affected by this, where he says, I don't have the quite the resolution with the pixels with the small scope, but it's working in a way that I'm still kind of undersampling, right, which is okay. And that means if the sky isn't the best, I can still get really decent images. And because I'm only tracking for a minute, I don't have to have such a demand on precise tracking like the guy with the C14 would do. So the guy with the C14 has got 5 times the aperture and 25 times the light gathering power, but yet, this is superior in all ways to doing your wide field deep sky viewing. So when the other guy, there are people like Christopher Goh is one who's excellent with astrophotography with his C14. Anthony Wesley is another one. So you have a lot of people that focus on planets. So now they're in the opposite place. They say, I want an image, I want my planet. So I'm going to, do this, precise tracking for a long time. I don't want to undersample and lose resolution. I want to really get as much resolution as I can, right? So we see like different purpose, just, different scopes that you need to accomplish this. But what you get at the end of the day with these is phenomenal. It really is. So if you're looking at the planets first, when they see the images that people are producing now, they are, without exaggeration, like with Jupiter, like what the Voyager space probe saw on Jupiter as they flew by. It's like that good, right? And they are able to produce things like movies of the red spot. And it's not just seeing the red spot of Jupiter, it's resolving the red spot, resolving features inside the red spot, and showing in the movie how they rotate around with the spot. I mean, I'm just blown away. And if you're talking about trying to contribute even to science, and you have records of this, this magnitude, that's phenomenal. But boy, it's a lot of work and a lot of effort and a big learning curve to do that type of thing. And the other side, doing deep sky with this kind of thing, the images you're getting are phenomenal again. They are comparable to what the best observatories did 50 years ago with their photography. So you're getting gorgeous images of nebulae and galaxies and resolving tremendous details you could never do visually, right? So that's the upside of doing this. Then the downside of doing this is it's a big learning curve. It's a lot of money. This small scope, you need to spend around $3,000 or so for the scope and equipment to kind of get started to get this going. And it's just a different experience. It's all like a machine doing the seeing for me. So it's a different way of experiencing this. There's no right or wrong. It's just a different way approach. So this is becoming popular not just because of what you can accomplish, but also just you can defeat light pollution in a way by going electronic, right? So you can sort of compensate, but still imagers tell me that we need to get better skies too. If we get better skies, we get better images, right? So light pollution still affects them too. So the last one I want to talk about is this thing. This is a sea star. So this is like the latest thing that's out, and this is nothing like any traditional telescope whatsoever. So now what they've done, this is around $500, and you've taken all this software and things that imagers do, and you just put it all in there. So the learning curve and all that is way reduced, right? And so all you do is set it up. So I could set this up literally on my balcony in my high-rise in Chicago, and then use my cell phone or tablet to control it. Right? So this is very popular with people much younger than I am, who grew up with cell phones and tablets. It's second nature for them to use this and control it. So now I can set it on my balcony. Let's say it's really cold outside. I don't care. Just set it on the balcony, close the door, go inside, right? Nice and toasty inside. Don't have to worry about lights, because like I'm looking at a cell phone. That's my eyepiece. I keep all the lights on in the house. It's fine, right? You can have Netflix on the TV in the background, and then the scope will find objects for you and will show it right there, right on your cell phone or tablet. And then The quality that you'll have would be like, remember my Andromeda galaxy? So it'll be like about like that. I looked at images that this does, and it's like, oh, that's pretty comparable to what I'm seeing with my scope visually, from the dark sites, right? But now you're doing it, right, even in light pollution. So then I said, what about the planets? Okay, and I was like, oh my goodness, they suck, the planets. So we know why. It's like this is a 50 millimeter lens. So that's the equivalent of 50 millimeter scope. So that's really small. And then it's wide field, right? So it can try and zoom in a bit, but it doesn't do a good job of that. And as we remember before from my drawing of Andromeda and how small the planet is compared to the galaxy. So this really struggles. So it shows you a blob that is Jupiter, but it's not resolved at all. It can't even pick out the cloud belts very well. So it just doesn't, that's not its thing. But any kind of deep sky thing, it's wonderful. The other thing, so there are good advantages to this. So for people starting out and they like to get into the hobby, this is a completely different way of doing it, right? All electronic. And you can, it works for a lot of people starting out now because they are used to seeing great images of astronomical objects, and they're not going to be happy with like just seeing the galaxy as just this less resolved feature. They want it to look more like the pictures they're used to seeing. So this can do that, right? So it gets you a decent view of the Andromeda galaxy, nebulae, so forth, and have it right there on your cell phone. But the drawback is going to be it's more limited to that type of thing. Many people suggest this would be a great thing to do for outreach programs. You can take this out on the river walk, right? The lights are on, we don't care. And when you set it up, it'll find objects for you, and you can show it on something, a tablet or whatever, and show people, here's Andromeda, right? Whatever, and it'll look pretty nice. So it's good for that type of purpose too. So people who really do imaging, they don't like this, right? And they're like, what do you mean you can only do what Ron can do with this little refractor? We can blow that away, right? But it's much more involved then, right? So anyway, this is just giving you like a little sample or a little idea of the different ways that we can do this hobby. So ultimately, the best telescope is the one you use most often, the one you're eager to take out every clear night. Right, so thank you. Okay, so any questions?
Can you comment on accessories like different eyepieces or different filters?
Oh, sure. So, for example, with my short tube scope, so one of the drawbacks is it doesn't bring light into focus as you'd like to. So you can get what they call a V-block filter. And so that helps compensate for that. So you get more contrasty views when you're trying to do high power viewing. You can get other filters like red filter to see surface features on Mars, blue filter to help bring out details on Jupiter. Right? Then eyepieces. So my small scope doesn't magnify well, it's designed for wide field. So if I do want to zoom in on something like a double star, then I can get like a higher power eyepiece, right? And a Barlow lens. And so then I can get quite a bit of high power, even though the scope is very short and compact. And then again, if the optics are good enough, like mine is, it'll do a decent job with high power. So I can use over 300 power on it to split double stars and even look at features on Mars or a planetary nebula if the seeing conditions allow. So you can do things like that to help upgrade your scope. I did other things which I recommend, like I like finder scopes as opposed to telerads because of light pollution. Right? So a telerad was great if you had great dark skies, and then you see what you want because it's a nice dark sky, and the telerad just helps you see what the sky is, line it up good. But when you have light pollution, Now I can't see what I want to see so well, so I need help. So a finder scope will magnify and help bring out the stars so I can see them. I find it much easier to use. And it used to be in the old days, you'd have a finder scope that does everything upside down. And then that was a pain. I'd have to take my star charts and turn them upside down to match the finder scope. So an accessory I got was a right field view finder scope. So now when I look through the finder scope, it's exactly like I'm seeing it in the sky. I don't have to turn charts upside down. The same thing with the diagonals. They used to turn everything upside down and backwards. That was a pain if you're using charts and things. Now I got a correct view diagonal so that you see it exactly like your eye sees it. So it's even better than the Newtonian. The Newtonians turn everything upside down. Now with my diagonal, everything's right side up the way you like it. Those are like accessories that I really enjoy. You have some accessories that didn't work for me, like you had, here, buy this expensive diagonal, right? Because it has all the, it's like extra special glass, and it's supposed to make your views more contrasty. And it's like, nope, doesn't do what advertised. So some things don't work, but you know, a lot of things can, you know, and then as you can get those accessories on your scope, you can overcome some of the initial shortcomings they may have, right? Also get eyepieces that give you extra wide fields of view too, right? So then those are nice. And then certain filters for deep sky objects. So like I could see the Ring Nebula and the Dumbbell Nebula from my balcony in Chicago because I have a light pollution filter. And then it, you know, lets me see them, even though I'm in like the worst possible location to try and see them. So that's a nice accessory too. Yeah.
What kind of power do you need to see the planets?
So with that, the 200 power is a good one. And then you get into, if you go beyond that, then we're getting into atmosphere problems. So the scope, like a C11, could go much higher, but now we're not going to have the cleanest view because of the atmosphere, not the scope. But if the air allows, you can go much higher. You can go over 300 power, right? And the higher the power you can practically use, the better, because it just makes everything easier to see and pull out. And so I find, like for Mars, I tend to want to use higher power because I need it because the disk tends to be small. With Jupiter and Saturn, I don't need as much power, right? Because they're a little bit larger to begin with. So, yeah. Okay. All right. Oh, yeah.
This is a little off the exact topic, but one thing I came across was a firm that actually made available rented school that you could lease, and they have these in the mountains of New Mexico and other exotic places, but where they get 300 really good days of viewing every year, and you pay like a monthly fee, and then I think some hourly rate for however much you use the scope. And there's a range of different scopes.
So true. So you can do remote, use them remotely. That is, you are here in Illinois, the scope is there in the desert Southwest, and you are controlling it from Illinois and choosing what object you want to image. And so it's all with imaging. Exactly true.
So it's like your lanai, except a little more removed.
Yes, exactly. But true. So that is another option. Okay.
As one who's starting Naomi, would you recommend focusing on the planets instead of the deep sky first, and then
So in part, it's a personal choice of what's interesting to you, because what you want to do is build motivation. So it's whatever is capturing your fancy is what you need to do, right? And so maybe if you're not sure, then you can start looking at them first, right? And seeing what you find interesting. And so it's building motivation is a big key to this. So what did it for me, at least if I take it from a visual point, for the planets, I liked it because they're accessible. So then I avoided aggravation at first. It's like, how do I find it? Well, it's not a big deal. And then it would be, though, paying attention to what you're seeing. and you would have to develop visually a skill to see detail in the planet, because the atmosphere is always trying to blur the image, so you need a low patience with it. You gotta look at it for a while and try and train my eye to pick out detail. And then once you do that, then, you know, I was able to catch the red spot from my balcony once. And that's hard to do because that's very bad, right, seeing. But I trained my eyes so well, right, by all these years that I could do it, right? So just you develop a skill. And then the same becomes with deep sky, as you develop the skill of being able to notice things. So another thing I liked in developing motivation was how you find them. So I liked star hopping because it would be a challenge. Like some people like crossword puzzles. So it would be, well, here's a good example of the comet, the Shushan Shen. So a lot of us in the club were able to see it from Manuka, naked eye. I didn't have that opportunity. I had to see it from an urban location, like a park, not naked eye. So how do you find it? So when you do star hopping, you learn the sky. So I really like that part of it. And then because I did that, when I went out to the park, I knew then what stars I was seeing. Oh, there is Altair, there's Vega, and I know then from doing this that they make a triangle with Deneb, which would be behind me, that's the summer triangle, and it makes another triangle with the star of Ophiuchus called the Roth's egg. Now, the comet was in Ophiuchus. So now, it's, to find it, star hopping, I just go right away. Like, there's the brightest star in the constellation, boom. Now I just sweep from there to the comet. Very quickly, I have it. When you do, like, the go-to scope, then it doesn't work that way. I have to go out to the park, I have to find Altair, I gotta get the scope on Altair, pump it, punch it in, then I gotta move it to Vega, and get it to recognize Vega, then I can go to Rat's Egg, punch it in. By the time I'm doing all of this, I'm already viewing the comet, right? But also then for more challenging objects, it becomes like a fun challenge, right? Can I find this thing in the sky? And when you do, it's satisfaction. And then when you do that, it just builds your interest in it. And then it is paying attention to what you're seeing, like I showed with M13. Well, our eyes are drawn to M13, but there's more there than just M13. There's like the galaxy next to it. And with other objects, you'll find there'll be double stars that are there by the main object, or how the main object is framed by a beautiful star asterism. So you're appreciating much more than just the object itself. So that's how I get motivation, right, to keep going. And then you want to return to the objects and you see more than you saw before, or check out some of these other things that you noticed, right, while you were looking for the main object. Imaging-wise, you can build motivation, I'm sure, in what about the imaging that galaxy now that was next to M13, right? What does that look like? I can really do a lot more than any visual guy. I would think that'd be motivation. And so the more you learn about these things, the more interesting they become, right? And so it feeds on itself. You want to get out there and keep viewing. Yeah.
So where can you go for purchasing a good telescope, and is there a used market?
Yes, so there's definitely a used market. So there's one site called Cloudy Nights, and you can go on there, and they have, and Astromart is another one. So they are sites that you can buy used equipment at. Very good. I highly recommend that, because it's a way of getting things.
Is it Cloudy Nights? What was the second
Yeah, Cloudy Nights, and then Astromart is another one. Yeah. And that is for that. You have a company called Astronomics. They're based in I think Nebraska, and I bought from them directly. So they're one of the retailers that's still out there, and they sell a wide range of new telescopes.
They actually sponsor the Cloudy Night
Nights.
Correct. They sponsor Cloudy Nights, so that's a great outfit. There's a couple others that you can find online that sell. You get into like Amazon or something will sell scopes, but it gets a little more sketchy that way in terms of getting support, for that. But I would recommend those places for sure. So, okay, well, thank you all for coming out.